So it's time to keep pushing forward with our understanding of what's happening with the electrons. It's actually really kind of cool, the next jump that we're going to be going into. And it's really important to also understand where we came from, because science really is kind of this ever-changing and evolving thing. One of the things that I like the best about it is that even though we might have a really good idea about something, scientists are usually open to the idea that they're not permanent and that they can be open to change. It's really kind of cool. Okay, so I want to go back to note-taking mode. I'm going to share with you my board one more time. I would suggest that you should probably also grab some paper and jot a couple of things down as we're going, because there's a lot of stuff in here and it can get pretty complex. So let's go here. Okay, so now you should be able to see an image of my board, and we're going to start to kind of talk about a couple things again. We're going to take you all the way back. At the end of last chapter, the last scientist that you should have talked about was Ernest Rutherford. And he comes up with a model of the atom that essentially has this solid positive center and then a cloud of just electron goo around the outside with no real good organization. That's where we leave off. But the creation of the nucleus was a big, important thing. Then at the beginning of this chapter, we learn about Niels Bohr. And Niels Bohr comes up with the planetary model. And in his model, we have both the protons and the neutrons around the inside. And then around the outside, the electrons are now organized into these beautiful concentric rings. And those rings can only hold a certain number of electrons. So for example, on shell 1, you can only hold 2, shell 2 can hold 8, and then shell 3 can hold 18. Well, the scientist that we're about to launch into talking about, and this is where our new learning is going to pick up, is by the name of Schro, S-C-H-R, I cannot spell, S-C-H-R-O, with an umlaut, D-I-N-G-E-R, Schrödinger. And where the big difference between his model and Bohr's model comes in is how they treat the electron. In Bohr's model of the atom, the electron is only treated as a particle. So Bohr treats it like matter. Now, if it's matter and it's spinning around the nucleus, it's going to behave like a planet in a nice, neat, predictable path going around the nucleus like it's the sun. Planets orbiting the sun. Now, it involves a whole different type of math than what Schrödinger develops. And again, it's in how he thinks about the electron. Schrödinger instead says that the electron, because it's crazy tiny, and when matter gets crazy tiny, it starts to break the normal rules of physics. We say it starts to obey something called quantum mechanics. It's pretty neat. What that really means is that the electron is simultaneously thought that it is really a particle and a wave. It's both. Now, when I say wave, I quite literally mean like it is traveling like waves at the ocean, which is kind of cool. Energy does that. So at some point when it's almost so small that we can't tell that it's matter, it almost becomes more like energy and behaves more like energy does, traveling in a wave. So what Schrödinger does is he takes this idea and says, okay, so instead of these perfect rings then, what if I draw this more in like waves? What is it going to look like? So we're still going to have the proton and the neutron in the center. But now instead of these perfect rings, you can kind of start to imagine, and I'm going to draw this terribly, and this is really not the true model of what this ends up looking like. This is just convenience for right now, so we can kind of figure it out. The electrons now move around the outside, still in energy levels, but now they're moving more like this wavy business. What I love about this is that we go from essentially hot mess and no organization to perfect order and beautiful organization to looks messy, but there's a lot of order there. Okay, so there's only one more problem with how we've drawn this. This is still two-dimensional. Bohr's model never really leaves two dimensions, and that's not true of matter. Matter is really three-dimensional. So Schrodinger actually takes the time to mathematically develop his picture into a 3D shape. I want you to imagine that you're almost gonna put this on like a little skewer and then try and spin this around in three-dimensional space. Gonna get some funky pictures, like totally weird pictures. I'm actually going to share my screen with you right now. Now, this isn't a perfect simulation, but it's at least a good idea of what it looks like to spin a wave around in 3 dimensions. What's really kind of neat is you can actually get some really cool pictures. So this is, again, an idea of what it looks like to spin a wave around in 3D. And the last bit that's missing from this is, now remember, this is a flat wave. Waves around the nucleus are wrapped in a ring. Like, it's crazy. There's so much going on there. So let's keep moving around here. Let's stop this. Let's bring this back. And then let's make sure that I share with you my notes, because we still need to take some notes from this. So really what we need to try and figure out now is, what pictures did Schrodinger actually come up with? What are these shapes that are on the inside of these rings? Okay, so you should be back to my board now. Let me erase that quickly. Okay, so the first shape that Schrodinger develops is something called the S shape. It looks a little something like this. It's just a solid, beautiful, lovely little sphere. Now, these shapes are called orbitals. An orbital is a place where 2, and exactly 2, electrons can live. So this is the first picture that Schrodinger develops for an orbital. Now, this is a shape on the inside of an energy level. I think we should probably put that down too. A shape inside of an energy level. S. So inside of this shape, you can actually fit 2 electrons. Now, it's a very simple shape. So as he changes the math a little bit, the shapes can get a little bit more complex. The next shape that he comes up with looks like this, a little dumbbell shape, which is pretty cool. And he calls this shape P shape. But he didn't just come up with one of them. Notice that this has like a direction. This one's up and down. He also realizes that he can make one side to side. And you're going to have to use your imagination for this one, but you can also make one front to back. So I want you to imagine that this one is actually going into and out of the plane of the board. I'm going to have to draw it like this for right now. So each one of these shapes can hold 2 electrons. So this is 2 and 2 and 2. So P can actually hold a total of 6 electrons. S can hold a total of 2 electrons. Now there's one more shape that I'm going to teach to you, although there are 4 total. I'm only going to show you this next one because it's a kind of crazy one. The next shape is called D. So this is called D-Orbital System. Now, in each one of these shapes. Now remember, these are shapes on the inside of an energy level. Crazy. 2 electrons, 2 electrons, 2 electrons, 2 electrons, 2 electrons. With 5 total shapes, that means that in the d-orbital system, you can hold a total of 10 electrons. Really totally wacky. Now, not every shape is held on the inside of each one of the energy levels. We'll go over that in the next video. Now, just before we leave this concept, and because you might be curious, again, there is a 4th shape. There would be 7 of them, by the way. 7 of these next kind of shapes. It's a shape that looks like this. It gets just more and more complex as you go further and further away from the nucleus. This is called an F shape, and there's 7 of them, and it would hold 14 electrons, but that's way past what you need to know. What you need to know is that we start with an S shape that can hold 2. There are 3 P shapes. Each one of them holds 2. That gives you a total of 6. And that there is a D shape. Each one of them holds 2 for a total of 10 electrons. Again, one more time, not every shape is on every energy level. We're going to go over what shapes are on what levels and how many electrons fit into them in the next video.